we have to assume here that both paratroopers, both men, are stationary when they first leave the helicopter. So let's look at the first man out. Basically, his initial velocity will have to be 0. His final velocity, well, we don't know that, we don't really care. His acceleration is going to be 9.8 meters per second in a downwards direction. The distance, let's say that the distance that he travels vertically downwards, let's just call that S1, and that's in a downwards direction, so that's his displacement. And the time taken, now basically the question says the time taken after the second paratrooper leaves the helicopter. So if we look at the first man, his time that he's going to be in the air for is going to be 2 seconds more than the second man. So his time is going to be t plus 2. And if we now use s equals ut plus half at squared, so just using s equals ut plus half at squared, substituting into that, we're just going to get the distance that his displacement is going to be, u is 0, so it's going to be a half multiplied by 9.8 multiplied by t plus 2 squared. That's for the first paratrooper. Sorry, that's meant to be an 8. Okay, if we now look at the second man, we can do a similar thing. Excuse my writing, I forgot to bring the tablet home. U is equal to 0 for the second man. The acceleration is again 9.8 in a downwards direction. What else? The displacement for the second man, let's just call that S2. And the time for the second man, now that's just going to be t, because we're taking t to be the time that the second man is in the air for. Now we can just do the same thing, easy enough, find an expression for S2. The difference between the heights then, for the two of them, is just going to be S1 minus S2. I'll leave you to figure that out, and it comes out as the answer in the back of the book, 4.9. Well, it's 4t plus 4 multiplied by 4.9, but that factorizes to 19.6 multiplied by t plus 1. I'll leave you to do the algebra bit there. This question then says draw a graph of the two. Well, if you do a graph of one against the other, if horizontal axis, we're going to have t, and again t is, sorry, let's write t over there. T is the time for which the first one is out of the aeroplane, so we're going to have t going 0, 1, 2, 3, and so on, 4. And the graph is actually the distance between them, so the height between, the difference in height between the two. So when t is equal to 0, the distance between the two is going to be just 19.6. I'll just stick that there. So when t is 0, the difference in height between the two is 19.6. When t is 1, the difference between the two is going to be 2 lots of 19.6. So I'll just write here 2 times 19.6, and so on. And in fact, what you get is a straight line graph, which is going to look something like that. 19.6, 2 times 19.6, 3 times 19.6, and so on. Now, it's a bit difficult to understand the sort of, what they ask you now is the sort of what speed the first one appears to be travelling at, observed by the second one. Now, the second one is obviously behind. The difference in height between the two is 19.6 meters to start with, and then 2 lots of 19.6 meters. So the distance between the two is increasing by 19.6 meters per second. In other words, it appears if the distance between the two stayed at 0, they were traveling they were at the same height, then it would appear as though the first and the second were just going at the same speed. In other words, it would appear to one of them that the other one was traveling with no speed at all. As it happens, the first paratrooper is 19.6 meters always more ahead of the first one, so it appears as though the second paratrooper is traveling at 19.6 meters per second.